afternoon, Algebra 2 Essential students. I hope you guys are having a great day. Had a good morning, now afternoon, working on your review for the Chapter 1 test. So here we go. I am going to go kind of through it a little bit quickly so that the video isn't super duper long. However, if I'm kind of timing it a little bit, if it gets long, it might be broken into two pieces. All right, so number one, great review of 1.1. It says, given each sequence below, identify if it's arithmetic, geometric, if it's increasing, decreasing, common difference D, again, that's arithmetic, common ratio R, that is geometric. Okay, so, all right, if I look at the first one here, I go, 200, 180, 162, 145, that already tells me that, wow, I know that's, whoops, sorry, I almost wrote increasing, that's decreasing, it's going down. That's probably the easiest thing to define. Well, I'm thinking 200 to 180, that's like losing $20 or $20. I sometimes do it to money. If I subtract another 20, that's actually 160, not 162. So that already tells me that it's geometric. So now I need to figure out the common ratio. Remember how to figure out the common ratio? You take the next term and divide it by the previous term. So I'm going to use that concept here. So if I go 180 and divide it by 200, quickly on my calculator, I go 180 divided by 200, and voila, look at that. I get my R to be 0.9. So I can check it real quick by going 200 times 0.9, enter, then times it by 0.9 again if I want to, hit enter a couple times, and look at how that lines up. All right, let's take a look at the second one. 14, 22, 30, 38, 46. Oh, I can see it's going up, so I know it's increasing. Let's see, 14 to 22, if I subtract the two, I can't figure it out right away. I can always just use my technology, okay, is 8. Well, 22 plus 8, yeah, that's 30. 30 plus 8 is 38. So I know that this is arithmetic, and I've actually figured out the common difference is a positive 8. Wow, that one went quick. All right, next one, 26, 19, 12, 5, negative 2. Ooh, I see that that one's decreasing. It looks like it's going down. 26 minus 19 looks like 7. 7 or 19 minus 7 is 12. 12 minus 5 is 7. So I know this one is arithmetic. It is decreasing, and I am subtracting 7. Okay. All right, the last one, 40, 60, 90, 135. Wow, that definitely is increasing. How is it increasing by? Well, let's see here. It goes by 20 and then by 30. Ooh, that tells me it's not arithmetic, must be geometric. So if I do the next divided by previous, 60 divided by 40. So let's do that on my calculator real quick. Some of you probably already know that that's 1.5 or 1.5. So my R is 1.5. All right, that takes care of question number 1, lickety split. I hope they all go that fast. All right. So let's take a look at here. Oh, notice how, oh, isn't this nice? Boy, Mr. Parts, aren't these sequences exactly the same? So here's what's really cool is I got all this stuff kind of already done for me. So I can write the recursive formula. And then it asks me to find u sub 8 for each of these. All right, so now to do the first one here, I'll try to stay the same color. U sub 0 is the first, oh, not u sub 0. My apologies, since we're talking the general one here, this is u sub 1, okay? So you gotta be careful if you use your calculators on these. So, and I'll talk about that in a second. So u sub n equals u sub n minus 1. So according, if I'm using R, that means multiply times by 0.9. So now I'm trying to find, okay, u sub 8. So what I can do is, if I do the last answer feature, this will take a little bit of time, but I think it'll be just as fast as doing it the other way. Times it by 0.9. So I know that's term 1, term 2, so 3, 4, 5, 6. Hope I made that. Whoops, I think I kind of messed up on my counting. So 145 is term 4, 5, 6, 7, whoops, 8. There we go. Just want to make sure. 1, 2, 3, 4. So 145, which is kind of right here, is the 4th term, 5th term, 6th term, 7th term, 8th term. So u sub 8 is 95. Let's just say 0.66. We'll round to 2 decimal places to kind of keep it simple. All right, next one. We knew it was arithmetic. So u sub 1 equals the first term always, 14. We always write u sub n equals u sub n minus 1. So in this case, we were simply adding 8. That's why I like to write the plus and minus symbols with the differences, so I know if it's a plus or minus. So now, right, u sub 8. So this one should probably go pretty quickly. So I go 14, and I know I go plus 8. Gives me the second term, plus 8. Gives me the third, fourth, fifth, sixth, seventh, eighth. Look at that. U sub 8 is 70. All right, just like that. 2 down, 2 to go. All right, next one we know was arithmetic again. So I define that first term. U sub 1 is 26. So then u sub n equals u sub n minus 1. And then this time I was subtracting 7. All right, so trying to find u sub 8. So let's find that in there. So we start with 26, and I subtract 7, enter, subtract 7 again. So there's term 3, 4, 5, 6, 7, 8. Negative 23. Some of you might even think, why don't I just start with this one, know it's number 5, and then just do 6, 7, 8. By all means, do it that way. Maybe I'll do the last one that way for you. All right, so the last one, my first term again was 40. So then I go u sub n equals u sub n minus 1. According to our rule, it's r, so it's a multiply by 1.5. Now I look at u sub 8. So what I was saying before is you could start with the 135, okay, since we already know the pattern, and I know that's the fourth term. Times it by 1.5. That's the fifth term. Times it by 1.5. Sixth term, seventh term, eighth term. Yeah, you don't have to do it so many times. That might have been a little faster. Oh, that's kind of smart. Some of you were already probably half a step ahead of me with that. All right, just like that, 2 problems done, a bunch more to go. All right, number 3 is a great review of 1.2. This is where we're just kind of writing it in the ratio form. So we want to find, in essence in here, we're just trying to find r. So remember, decay means decreases. So this is going to be 1 minus p. So we go 1 minus, remember, change it as a decimal, 0.04. If you left it as that, I'm okay with that. If you wrote 0.96, I'm great with that too. I would accept both answers. All right, next one, appreciate. Remember, that means increases. So that's like 1 plus p, but again, move the decimal over 2 spots. So if you wrote it as 1 plus 0.062, I'm fine with that. If you wrote 1.062, I am great with that too. All right, last one, depreciate is like saying decay, going down. So move the parentheses over. So again, this is like doing 1 minus p. So I'm going in parentheses 1 minus 0.08. You left it like that, I'd be fine with that. Or if you wrote 0.92, hey, I love that answer too. All right, just like that, we finished the first page of our review. Let's keep plugging away. All right, so now we're going to get into kind of the recursive stuff, and we're going to probably start using our calculator a little bit more. So number 4 here already, it says, suppose you deposit $1,500 into a savings account that pays you 3.2% annual interest and no more deposits or withdrawals are made. Write a recursive rule formula if the interest is compounded monthly. So compounded monthly means 12 times a year. So as we write this recursive formula, since it's a context of a problem, that means our recursive, we start with u sub 0 as our starting amount. So we deposited $1,500, okay? So u sub 0 equals 500. So then we go u sub n equals u sub n minus 1. And so now we go, okay, how is this going up? We're going 1 plus interest rate, changed as a decimal. So move that decimal over 2 spots, 0.032. But since we're doing it monthly, we gotta divide it by 12. Okay? All right, so just like that, got A done. B says, how much money will be in the account after 2 years? Okay, so if I think about it, I'm doing it 12 times a year times 2. I want to find u sub 24. Okay, so this is where the recursive formula helps so much on our calculator. I'm going to go to my y equals, and hopefully I'm still in this mode. So I can see that it's equal to 0 here. That's always important that that matches up. Remember, keep this u sub n minus 1 piece in there. If by some reason you deleted it, remember to get the u, you go second 7, parentheses, and then the n is right here, n minus 1, close parentheses. But a lot of times, I don't even delete that part. So now, I can come in here and start typing it and changing it. 0.032, and I'm dividing it by 12. Close my parentheses. My initial value I started wasn't $500, it was $1,500. So if everything looks beautiful there, I'm looking for the 24th term. So I go to my second window, my table set. I don't want to look for the 104th term, I want the 24th term. Hit enter. So then I can go to my table, so second graph, and look at that. Highlight 24, and look at that. I have $1,599. Wow, I've almost made $100 in 2 years in interest. That's kind of nice. Okay. All right. C says, write a recursive formula if the interest is compounded weekly. So now weekly, remember, weekly means 52 times a year. So all that changes is this number 12 becomes a 52. So we just go u sub 0 equals 1,500, u sub n equals u sub n minus 1, okay? And this part is exactly the same, except that 12 now becomes a 52. So what's nice is, if I go back to my y equals, the only thing I really have to do here to change it in the actual formula, you can see I'm kind of slowly going over there. You guys can probably get it faster. I'm changing that 12 to a 52. Okay? Now, the other thing that changes is it says how much money will be in the account in 2 years. Now it's not 12 times 2, but it's 52 times 2, or 104. So I want u sub 104. So wow, so I actually wanted that kind of 104. So I go back to my table set, change it to 104, go to the table, so second graph, let the calculator think for a little bit, and if I look there, okay, you might be saying, well, Mr. Bart, it's not a whole heck of a lot difference, but it is a little bit, $1,599.11. So that answer, actually, you get 11 more cents if you got it weekly than monthly. All right, that takes care of number 4. All right, let's take a look at number 5. Ooh, number 5 says, you have saved $300,000 in a retirement account. Lucky. Each year you withdraw 5% of the balance and you are able to deposit $6,000 into it from other investments. Ooh, write a recursive formula for this problem. Okay? All right, so for this one, let me switch colors. Sorry, just kind of like to change it up. So u sub 0 is the starting value. So that's what we start with, $300,000. Wow. Okay. So then we go u sub n equals u sub n minus 1. Okay. Now, you're going to withdraw. So you're going to take away. So what happens there is we're going to multiply by 1.05, okay, because we're taking that amount away. However, we're able to put $6,000 back into the account from other investments and stuff. Sounds good. All right. So all we had to do is write the recursive formula for it. So in part B, it says how much money will be in the account in the long run. So really, you could put it in the calculator and then just keep on going, you know, year after year after year after year. But remember, long run value is a nice formula. So when we're talking about long run, I like to abbreviate long run value. Remember how this value is found by taking the adding amount and dividing it by the percentage of decrease. Okay? So in our case, we were adding $6,000 each and every year. The percentage of decrease was 0.05. So let's see what happens here when we actually do that. So 6,000 divided by 0.05 gives us $120,000. Wow. Woo-wee. All right. Sweet. Just like that, we got 2 pages of the review done and only a couple more pages to go. All right, let's take a look at number 6. Oh, this is a good review of, I think, 1.3 here. So it says the elk population in Yellowstone National Park is under federal protection. This research indicates that the population is decreasing at the rate of 8% per year. Federal government proposes to introduce 200 additional elk in the area every year. Current elk population is 850. Write the recursive formula for this definition. So this one's kind of like number 5, just now putting it in a different terms. So U sub 0 is our starting elk population. So the starting elk population was 850. So what's going to happen with our elk population, U sub n equals U sub n minus 1. So what happens is it's decreasing at a rate. So probably, natural death and being killed by predators, probably like wolves and bears maybe, probably mostly wolves. Okay, so I go 1 minus, change that percentage to a decimal, so minus 0.8. However, the government's going to introduce 200 additional elk to the area. So I got my recursive definition. So then in B, it's just asking again for that long run value. So if you remember that formula on the previous page, we take the adding amount, 200, divided by the percentage that is decreasing by. We're trying to figure out that balance point. 200 divided by 8%. So 8% of what number is 200? 2,500. So the long run value will level out at 2,500 elk. All right, pretty nice. All right, number 7. Ooh, now we're getting to some of my favorite problems. All right, so number 7 here, it says, suppose you've racked up $3,500 of credit card debt. The credit card company charges you an interest annual rate of 18%. That's usually a percentage. It's high. Compounded monthly. Wow. You have decided not to charge anything more to the credit card and plan to make $200 payments until the card is finally paid off. So the first thing we need to do is write the recursive formula, okay, that would calculate the balance of our credit card debt each and every month. So, we racked up $3,500 worth of debt. Dang it. What were we buying? Probably some pretty nice stuff. So our starting value is 3,500. U sub 0 is 3,500. So then U sub n times U sub n minus 1. So remember, they add the interest rate. So this one, unlike the previous one where it was minus and plus, this one's going to be plus and minus. So it's 1 plus the 18% interest. But remember that it's done monthly. So that gets divided by 12. Don't forget that piece. Otherwise, you're going to have some issues with this problem. You're going to say, why is it going up so fast and I'm never paying it off? Okay? But how much do we pay off each and every month? I thought it said 200. There it is. We make $200 payments. Whoops, I almost kind of crossed it out. So I get to decrease my monthly bill by $200. All right. Wow. So B says, what term of the sequence will show the balance of the credit card after 1 year? And what will that balance be? Well, we're doing it monthly, so we know that after 12 months. So I want to figure out what's the balance after 12 months. So it's calculator time. So let's type in the formula here. So I keep that U sub n minus 1. Remember, don't mess that part up. So we do go 1 plus, but now it's going to be 0.18 divided by 12. So I just type right over it, close my parenthesis, but then I get to subtract $200. So what's nice is I can kind of see what I have typed in there. Now my balance, don't forget to change this, was $3,500. Okay. So now when I go to my table set, I'm actually going to start it at 0 on purpose. Because what I like to do is I just like to make sure it kind of makes sense. I started at 3,500. It should be going down, a little bit less than 200 because, remember, I'm subtracting 200, but I got a lot of interest to pay. So you can see, wow, $52 in interest that was assessed to me that first month. That's a lot of interest. They're going to make a lot of money off me. So if I take a look here, I want to look for U sub 12. So I'm going to kind of go use the table way and just kind of keep on going down there. So remember, it's $1,576 Don't look at it here, look at it down here. Make sure you get it to the right penny. Many of you are going to write 40 cents, but it's actually 42 cents. Okay? All right, so now how many months does it take to pay off your credit card? I only have $1,500 left after a year, okay? And I'm thinking 200, my guess is I can probably keep on scrolling probably 7 or 8 more times, and I think I'm going to get there. So remember, we go to the first negative number. It kind of accidentally jumped too much there. So how many months does it take? It takes 21 months. So I look for the first negative. So again, look for the first negative value. Okay. So now, how much did you actually pay for, okay, the $3,500 debt? So remember how this works. Okay, so we paid $200. So this was my payment. I need to multiply that by 21, which was the number of months that I paid $200. However, that last month, I overpaid by, and that's where the calculator is so unbelievably helpful. It doesn't want to cross my A there. Okay, I highlight this. I overpaid by $109.40. So now I got to do that quick calculation. Okay. So I'm going to exit out of here. So let's see, 200 times $21, but I minus 109.40, and I actually paid $4,090.60. Wow, $3,500 I charged up, and in the end, just by doing this payment plan, I'm going to give the company almost $600, $590 in interest over that year and a half. That's how the credit cards are making money off us. All right, last page here, number 8. Ooh, we get to talk about student loans here. I think this might be our last problem. So, yeah, many of you are going to go to school and you might be taking out some loans to go to college, okay? So here it says, suppose you have a total of $24,000 in student loan debt from going to college. Loan company charges you 4.8 annual interest on your loan compounded monthly. You just got a nice paying job and you're able to pay $450 a month towards your student loan debt until it's paid off. So it says, write a recursive formula that would calculate out the balance. So this one's very much like the credit card problem, just different numbers. So my u sub 0 is how much debt I started with. $24,000. Okay? So then u sub n equals u sub n minus 1. And now I go 1 plus that interest rate. So the interest rate was 4.8%. Remember, change that as a decimal, 0.048. Gonna move it over 1, 2. That's why that 0's there. Divided by 12 because it's compounded monthly. However, I can pay $450 a month, so I get to subtract $450 from the final statement. All right, so now let's keep on plugging away here. B says, what term of the sequence will show the balance after 2 years? Okay, I do 12 months a year times 2 years, so I want to figure out what u sub 24 is. So to get that, we go back to our calculator. So I got to change this equation. So u sub n minus 1 times, hopefully you didn't clear it out. Remember, second 7 for the u, parentheses, the n is right here, minus 1, oh, I'm sorry, minus 1, don't do the negative, do minus 1. That's always one of those little catches that some students do. Anyway, getting back to this problem, 0.048 got divided by 12. You'll start to see that I kind of type over it, but I always peek at it just to make sure everything's lining up nicely. So 1 plus 0.048 divided by 12 minus 450. Looks like I got that all right. Except my starting value, I'm starting off not with $3,500 worth of college debt, which would be a lot nicer than $24,000 in college debt. A lot of debt. All right, table set. I'm going to start at 24 because I just want to go right to 2 years. So if I take a look at it, wow, look at that. Still, after paying that college debt for 2 years, I've taken off a large chunk, but I still owe $15,101.48. If you're wondering where am I getting the cents from, again, look down here, round it to the nearest penny. And yes, the banks will keep you to the nearest penny. All right, how many months does it take for you to pay off your student loan? Wow, if I look at this, okay, and you think, oh my goodness, how am I going to actually find that number? Where should I even start? Okay. Some of the tricks that I'll do is, say if they didn't charge any interest at all, I took 24,000 and divided it by 450. Okay. So I'm going to kind of do a little trick here. 24,000 divided by 450. No interest whatsoever. It takes 53 months. So on my table set, I'm actually going to start right there at 53. Okay, so go ahead and hit enter, go to my table. I'm going to start at 53 and see if I get there. Look at that, finally. I get there finally at month 61. So it takes 61 months to pay off the student loan. All right, so how much did I actually pay for my college debt? So this is not necessarily for my college education, it's all for the loans. So remember, we're paying $450 a month. I'm going to times it by 61, which is the number of months. Oops. But on that 61st month, if I highlight it, this is how much I overpaid by. I overpaid by $401, not 50 cents, but 51 cents. Ooh, that penny makes a difference, right? So let's calculate that out and figure out how much I actually paid on that, on this college loan, or all my college loans. Okay. Whoa, something went awry. Look, I subtracted 44. So I'm going to kind of clear that and type. I mistyped it. 450 times 61. That's why I always kind of subtract 401.51. Wow, $27,048.49. So I had to pay an extra over $3,000 on my college loans. Yeah. All right, that takes care of the review. Hopefully you feel ready for the test. If not, email me, let me know. Schedule a Google Meet, and we'll get yourself ready for your test. All right, have a great day. See you tomorrow.